Hi, my name is Londiwe Ngomane and I'm a postgraduate candidate in chemical engineering. Today I was presenting at the Phoebe conference and presenting on my topic, which is the characterization and synthesis of banana peels, eggshells, and seashells for the application, which is in the treatment of wastewater. And during this process, we use a very simple process that's used also in industry, but we changed the chemicals, or we're moving away from chemical coagulation into a more natural based coagulation process. So now, I honestly believe that with this project and this research, it could be implemented in industry. And hopefully, if it all goes well, it will be soon, because we are in a very dangerous era where a lot of chemicals are being used in what we're drinking and what we're eating, and now we're trying to move away from that and go into a more sustainable and a more greener sort of living. So I'm very happy with this presentation. I'm very happy with this opportunity that the faculty has given us, and thank you. Been an increase or demand in the amount of industrial activities that have been occurring throughout the world. This has subsequently resulted in an increase in the amount of wastewater treatment or wastewater that has been produced from industries and into water treatment plants. And with this said, this water requires treatment prior to being disposed to the different water bodies. And this is because of all the contaminants that are found in this wastewater. And now the problem is that the methods that are currently used require quite a huge amount of chemicals. For example, polyaluminum chloride, you've got your ferric chlorides, which are chemicals that are used in treating water. But now these chemicals have an aging effect in humans. So we're trying to move away from this problem right now and go into a more greener solution. Another problem we're currently facing in South Africa is landfilling, where we've got bio-waste materials that are not degradable that are being dumped in landfills. Now, as the chair has previously said, with the bio-waste materials that are being disposed, they produce greenhouse gases. And he elaborated a lot on the effect of these greenhouse gases and how it affects the environment. So now we're not only looking at the treatment of water, but also we're tackling the problem that we have, which is landfilling here. So now, this also speaks directly to the United Nations Sustainable Development Goals of 2030, 6 and 12, which is clean water and sanitation, and also responsible production and consumption. The process that will be, or the process that is focused on when doing these biocoagulants is the coagulation process, which removes solids and contaminants in water during a water treatment process. So the pre-treatment of industrial wastewater using coagulation and flocculation process has become crucial in the removal efficiency of organic matter. And like I said before, the problem is that they use chemicals to treat this wastewater. And we're trying to find alternatives to actually replace this chemical and make it sustainable throughout these years. And the advantages of using biocoagulants or bio-waste materials is that they are low in toxicity, they are biodegradable, they are low in cost, and they are abundant resource of production and elimination of toxic risk to humans compared to our chemical or conventional coagulants, which are non-biodegradable. They're also dangerous to humans, like I have elaborated before. So the aim of this entire research is to find the best biocoagulants in these three that I'm using, which are going to be banana peels, eggshells, and seashells, like I have said. So I'm trying to investigate which is the best biocoagulant to be used in this research, with the specific objective of synthesizing the biocoagulant and also characterizing this biocoagulant. So for my methodology, all the chemicals that were used were bought from a local supplier in South Africa. The banana peels were collected from a local supermarket as waste, and also the eggshells were collected as waste in a local bakery, and the seashells were collected from a local beach. So these are the equipment that were used in this investigation to do the characterization, which includes the scanning electron microscopy, which deals with the morphology of the structure of the material that we're using, and also the energy dispensive X-ray, which shows the elemental components of this material that you'll be using, and the BET, which is the bronioemmet which shows the surface area and porosity of our material, the Fourier transform infrared spectroscopy, the FTIR, which shows our bands and also our functional groups in this material. And lastly, the X-ray diffraction analysis, which is our XRD, and shows the crystal structures of our material. This is the methodology of the process, where we've got our bio-waste materials, which were first washed thoroughly using deionized water and dried at 105 degrees for 24 hours to ensure that all the impurity for washing, all the impurities are removed, and also for drying to ensure that we have a pure substance, just what we need, our bio-waste material, followed by calcination, which is the exposure of our materials in high temperatures at the absence of oxygen, pardon me. And our banana peels were calcined at 400 degrees for a period of 2 hours, and our seashells and eggshells were calcined at 800 degrees Celsius for also a period of 2 hours. And after the calcination process, our materials were sent out and for analysis, the ones that I had said prior. So these are the results that we obtained, where A, B, and C are our materials prior to calcination, where you can see that after the calcination has occurred, the materials are seen to be more, have a better surface area compared to the others, and also they are more porous, which is what is needed for coagulation when applying our materials. And for the EDX, it has shown that prior to calcination, you have got a high abundance of carbon that is present. And after calcination, you have calcium and oxygen, which is abundant in all our calcined materials, which is something that is actually needed for the absorption of our contaminants and our material during the coagulation process. And the FCIR actually does speak to the other results and show that there is a presence of the OH stretching, OH bending, and also CH bending, which, like I said before, are things that are required for treatment or for absorption and coagulation. The BET affirms that our banana peels has got the highest surface area, which for the application we expect that the calcined banana peel will work or will have a better application compared to the other coagulants or biocoagulants. And the XRD shows the crystallization, like I said before, and these with the peaks here, here, and here, which shows that the materials that we have used are compatible or are going to work for our coagulation. Okay, so for the application of this project, we did a quick run to just test if our bio-waste materials actually work. And at a constant speed of 30 rams per minute, coagulant dosage of 3.5 grams per liter, mixing time of 15 minutes, and a settling time of 120 minutes, we have initially assumed, so that it is the calcined banana peel. It is the calcined banana peel that performed the best, which with a percentage removal of turbidity of about 75%, and our seashells, which performed the worst with a percentage removal of approximately 64%. So we can safely see that the characterization actually was in line with what was said with the application. And in conclusion, the SAMS images shows that the calcined banana peels had more voids and was more agglomerated compared to the other biocoagulants. And the calcined banana peels also had a higher surface area, pore volume, and pore size compared to the calcined seashells. And we can safely say that the calcined banana peel is said to be the superior biocoagulant. And thank you. These are the key references. And thank you to my supervisors and the rest of the team involved in this research. Thank you so much.
Thank you so much, colleagues. I think this was the most timed presentation, exactly on actually some few seconds to spare. So, can we just ask any questions that you quickly want to ask before we go for lunch?
Yes.
Enjoyed your presentation. It was great.
Thank you so much.
It really was good. Can you just tell me practical application? What are you going to do with this?
Okay. So practically, we're gonna use the coagulation. First, we're doing the lab scale right now, where we're using the coagulation process to actually try and see the effects it has not only. I only presented on turbidity today because I'm looking at only characterization. But for the application, we're going to look at contaminants that are found in municipal wastewater, and we're going to remove it using our biocoagulants, which, like I said, it doesn't contain chemicals, so it's low in toxicity. So the application is using the coagulation process to test our biocoagulants, and if our results are as we think they're going to be, hopefully scaling up, doing a pilot. Yes, so
we need to eat more bananas.
more bananas. Yes.
Any other question, colleagues? No other question? So I'm just, please, we are supposed to.
Miss Londiwe Ngomane.
Hi everyone, again. Today I presented my research and I won the award for Best Presenter, which is amazing. So I'm so excited for this opportunity again. I might add that it has really taught me a lot. I have grown a lot, and hopefully it's going to grow to bigger and better things. So yeah, thank you.
What comes with lunch at coagulants? Lunch for two.